Alrighty, hey guys, I'm sorry that I'm not there with you right now. I have a really bad sore throat, so I knew that I probably won't be able to make it through the whole day talking with you guys. So instead, we're going to do in class notes like this. So what we're going to be talking about today is the metric system. So I want you to go ahead and take notes like you normally would in class. Just like I was actually there. So let's talk a little bit about what the metric system is. So the metric system is a way to standardize units around the world. And we call it sometimes the system of international units. We got really fancy with that, or SI units. Okay. So a little example for you here. Sometimes we talk about the meter. We talk about the meter, and that would be a standard unit for length. So we'll talk about the meter, or the kilometer, or kilometer, or sometimes a centimeter. And I'm going to kind of delve into those examples a little bit more later. But all three of those are measurements of length or distance. So specifically, we've got some base units because they wanted to come up with these international units to use all around. And so you have to find what units are you going to use for what different types of measurements. So we have a bunch of different base units. So for mass, it's actually the kilogram, which is kg. Now that's kind of hard for us because kilo is actually what we're going to get into next, which is a prefix. So mass is a little bit tricky, but technically, and I am not going to lie to you, technically the base unit for mass is a kilogram. For time, the base unit is the second, or S. For volume, the base unit is the liter, or L. For distance, like I said, it's the meter, or M. And then for temperature, it's Kelvin, which is K, capital K, or you can also do temperature in terms of Celsius, or C, which is capital C. Okay? Now, because different things come in different sizes, we do actually have to think about something called prefixes so that we can convert between units, because not everything is going to weigh at least 1 kilogram. Not everything is going to take at least 1 second. And so we came up with these metric system prefixes. And that would be mega, which is capital M, and that is 1 times 10 to the -6, and oh, there we go, 10 to the -6. Oops. Okay, then we have kilo, which is K, lowercase k, and it is 1 times 10 to the -3. And then we have the base unit, which is whatever unit you're talking about, and that should be 1 times 10 to the 0, or just 1. Then we have centi, which is a little c, and that's 1 times 10 to the positive 2. We have milli, which is a little m, and that's 1 times 10 to the positive 3rd. We have micro, which I'm going to have to draw this one in. It's called the mu. It looks like a, sorry, it's the mu. It looks like, it looks like kind of a U with a tail or an M with a tail. But it's the mu, and it is 1 times 10 1 times 10 to the 6th. Kind of see a pattern going on here. Then we have nano, which is a little n, and that's 1 times 10 to the, somebody could probably guess this, 9th. And then finally, we have pico, which is p, and it's 1 times 10 to the 12th. Now, a lot of people have a hard time remembering the difference between pico and nano, and they always want to say that nano's 12 and pico's 9. And so the way that I remember it, and it's kind of backwards, and I'm sure that whoever's subbing for me is going to laugh at me, or you guys are all going to laugh at me. But I do it kind of backwards. I think of pico, pico kind of, a P kind of looks like a 9, a backwards 9, and so it doesn't go with it. So that's kind of the way I remember it, is that a P looks like a 9, so it doesn't go with it. It's kind of backwards to what you would think. But that's what we're going to be talking about today, and what I'm going to have you do next is make a, make a metric system flashcard for you to help you to work with these unit conversions, because what we're going to get into tomorrow is starting talking about unit conversions. But I do want to talk a little bit, I want to go back to this example with my meters and my kilometers and talking about prefixes. So if I have 300 and let's go with 3,530 meters. Now, a kilometer is 1 times 10 to the negative 3 of a meter, because meter is my base unit. So a kilometer is 1,000th of a meter, or there are 1,000 meters in a kilometer. So that would be the same as saying that I have 3.530 kilometers. And then a centimeter is 100th of a meter, or there's 100 centimeters in a meter. So if I have 3,530 meters, I have 353,000 centimeters. So I multiply it by 100. So we're going to get into that kind of unit conversions tomorrow. But just so you know, that's kind of what's coming your way, and that's what all these metric prefixes are. And that's why we need to make this metric prefix note card that we're going to make next, because I want you to be able to convert easily between these. And you're going to eventually have to have these memorized. So if the sub could go ahead and pause this video at this point to make sure that you guys all have everything written down, that would be great. So you can go ahead and pause it. I'm going to keep recording what we're going to do next. So if somebody could go ahead and pause the video, that would be great. Alright, so what we're going to work on next, now that you've got basic stuff about the metric system down, we're going to talk about making a metric system note card, because that's what's going to help us to get through metric system. And so the sub I'm going to have the sub pass out a note card to you, and this is your note card for you to use You do not get this note card on a test, so this is information that you eventually need to memorize. But for now, to help it as a guide, you can go ahead and we're going to make this note card. So take out that note card that they gave you and go ahead and use any of the colored pencils that I have out for you, and we're going to make this note card. So take a pencil or whatever you're going to use and draw a line along the note card. Okay, this is my number line. About 3/4 of the way on the right, I want you to draw a thick line. This is going to be your base unit. Okay, so this is where everything's going to start. This is your base unit. So I'm going to write some text in here, which you should write in as well. And I'm going to see if I can pause. All right, so these are my base units. And when I say base unit, what I mean is this is your grams, liters, meters, and seconds. Okay, so these are the base units that we have. Things without prefixes. Okay. Now go ahead and draw 5 lines and to the left. And you'll notice that I kind of did some special spacing there, and there was a reason for that. Okay, now this first mark is for centi, which, if you remember correctly, is C. C is my unit or letter that I use to describe centi. And centi, so I'm going to put this up here. So C was centi, and it's 1 times 10 to the second. Okay? After centi came milli. Milli was M, and milli was 1 times 10 to the third. Okay. And then came micro, which micro was weird. Micro was that really weird mu, which looks like an M or U with a tail. And that is 1 times 10 to the negative 6, or sorry, 10 to the 6th. Okay. Then we have nano. Another way to remember that nano comes first is that LMNOP, N comes before P in the alphabet. So N is for nano, and it's 1 times 10 to the 9th. And all the way out at the end is pico. And pico is P, and it's 1 times 10 to the 12th. Okay. Now these are all smaller than base unit. Which what that means is that there are many of them in one base unit, which is why all of their exponents are positive, because there are 100, or 1 times 10 to the positive 2 centimeters in 1 meter. Okay? Alright, now on the other side, you're going to draw just 2 lines. We're only going to go above by 2. And we're going to do the first one, if you remember, is kilo. Okay, kilo is K, lowercase k, and it's 1 times 10 to the negative third. That's what kilo is. And then after kilo comes mega, which is capital M, so as not to be confused with milli or meter. Capital M, and it's 1 times 10 to the negative 6th. Now, omega is larger. These are all things that are larger than the base unit. Which, if they're larger than the base unit, that's why there are fractions of them in one unit. Sorry, in one base unit. Which is why all of their exponents are, I'll try and get this out of the way, sorry. That's why all of their exponents are negative, because there's a fraction of them. Okay? With a line like this, something that's really important for you to remember is that in a situation like this, the base unit is always going to be 1. Okay? That's essential. This is the best way that I've found to do unit conversions, because you never have to worry about, is my exponent positive or is it negative? It is always one thing or another. Okay? Always one thing or another, which is why I like it this way. Now, some people don't like to do it this way because they like to have denominators when we start doing unit conversions as 1, and they don't want to actually have to divide by a number, in which case we can swap these around, and these can be negative and these can be positive. But I don't like that. I like always having the base unit as 1, so that it's never a question of whether these are negative or positive. If it's smaller, they're always positive. If it's larger, they're always negative. So that's how we're going to work through it this year. So I want you to make this note card, have it with you. We're going to use it, but you do have to memorize this stuff. So don't use the note card as a crutch. Use it as a guide to start you with when we start working on unit conversions tomorrow. But use it as a guide, not as a crutch. So start memorizing. So I'd like you to spend a little bit of time for the rest of class trying to memorize this, and then we'll get into actually some practice tomorrow when I'm back. Okay? Again, I'm really sorry that I'm not there. Be nice to the sub. Thank you, whoever's covering for me, for covering. I really appreciate it. And I will see you guys tomorrow.